Assalamualaikum, students of class 12. Hope by the grace of Almighty Allah, in this pandemic period, I'm going to deliver a lecture on sampling, which is the part of statistics second paper for the students of class 12, especially for the students of English version of class 12 who have the subject statistics. This is Muhammad Ashraful Azim, lecturer in statistics of Rajagupta Model College, is going to deliver the lecture. The chapter is 8, namely sampling. In my previous class, I explained what is sampling. I would like to repeat the definition of sampling. Sampling, it's a procedure, it's a system, or it's a method by which statistical method we can collect a sample from population. That is known as sampling. Today there is a problem, and it's very most important problem. This problem you will get in a creative question of the chapter, and this chapter is the part of group A. You know that in your question paper, especially in creative question paper, there are two parts, group A and group B. In group A, there are 4 questions, 4 set questions. Out of 4 CQ, you will get 1 CQ from the chapter, and in that CQ, this question is highly important. Now, the problem is a simple random sample of size 2 is drawn without replacement from the population 357. Now show that sample mean is an unbiased estimator of population mean. I repeat the question: a simple random sample of size 2 drawn. There are 2 systems. One is with replacement, or without replacement. In both systems, we can collect the sample from population. Now, our problem is collecting the samples from population without replacement. So, we are going to draw or select or collect the sample of such 2 from the population, which size is 357, its elements, and the system is without replacement. After that, we will test that sample mean is an unbiased estimator of population mean. Now, when it is with replacement, then population number of samples will be capital N to the power small n. What is the meaning of capital N and small n? Capital N means the size of population, and the small n be the size of sample. And if it is without replacement, if we collect the sample without replacement, in that moment it will be NCN. That is n to the power n, and NCN be the number of samples. When you collect the sample with replacement, then it will be n to the power n, and if we collect the sample without replacement, then it will be NCN. Now, from question we get the population size is 3, because 357, this is the population, and here there are 3 elements, so population size capital N equal to 3. Again, the sample size is 2. Here n is 2 and capital N is 3. By this sense, when you collect the sample with replacement, in that moment we will get 3 squared, that is 9 samples. On the other hand, if we collect the samples without replacement, in that moment we will get 3C2, that is 6 samples. Let's see. 3C2, this is 3 factorial divided by 2 factorial into 3 minus 2 factorial. So this is 2 into 1 and this is 6, this is 3. That is, when we collect samples without replacement, then we will get 3 samples. Anyway, in that moment we are going to solve the problem. Before going to solve the problem, I would like to the mathematical form of the question, that is, show that sample mean is an unbiased estimate of population mean. Let us consider the population is denoted by capital X and the sample is denoted by small x. The mean of x is x bar, this is also x bar. So x bar be the mean of capital X and small x bar be the mean of sample. Now, when it is expectation of x bar equal to capital X bar, this equation indicates the sample mean is an unbiased estimator of population mean. So to test the unbiasedness, if it is possible to prove expectation of x bar equal to capital X bar, in that moment the statement is verified. Now solution. Firstly, let population x equal to 357 and population size capital N equal to 3. Small x indicates sample, so and sample size small n equal to 2. Now population mean x bar, which is equal to, simply x bar means the average, so average equal to 3 plus 5 plus 7 divided by 3, that means 15 divided by 3, so capital X bar equal to 5. Therefore, we get the population mean is 5. Now, if we can calculate the expectation of small x bar equal to 5, in that moment, this statement is justified. Since samples are taken without replacement or replacement. So number of samples equal to NCN, that is 3C2, that is 3. 3 factorial divided by 2 factorial into 3 minus 2 factorial, and this is 3. That means we get only 3 samples when we collect the samples without replacement. Now the samples. Samples and sample mean. There is there 3, 5, 7, only 3 elements of the sample. It will be 3, 5, then it may be 3, 7, and it may be 5, 7. Without replacement, if the sample size is 2, from these 3 elements we can write only 3 samples, which are 3, 5, 3, 7 and 5, 7. There are only 3 samples. Now their mean, their samples are x denoted by small x, and so their mean is denoted by small x bar. Now the mean is 3 plus 5 divided by 2, that is 8 by 2, that is 4. Another one is 3 plus 7 divided by 2, that is 10 by 2, that is 5. And lastly 5 plus 7 divided by 2, this is 12 by 2, that is 6. So we get the sample mean or 4, 5 and 6 successively. Now total summation x bar equal to 15. The summation x bar equal to 15. That is this plus this equal to 15. Now we get summation x bar. We also determined capital X bar. By definition, dear students, by definition, expectation of x equal to summation x probability of x. This is the mathematical form of mathematical expectation of a random variable. Therefore, expectation of x bar equal to summation x bar probability of x bar. Probability of x, sorry. So, summation x bar, it was 15, and probability of x, that is probability of a sample, is 1 divided by 3. Why? Because we know that probability of an event is equal to number of all elements of an event divided by number of sample points, number of sample space. Here there is only one sample will be collected, so n of a equal to 1, and number of all elements of the sample space, since sample there are only 3 samples, so this is 3. N of a equal to 1 and n of a is equal to 3. By this sense, probability of x equal to 1 by 3 and summation x bar equal to 15, which is determined by making a table. And find now this is 5, so expectation of x bar equal to 5, which is equal to capital X bar. Finally, we see that expectation of x bar equal to capital X bar, which implies that the sample mean is an unbiased estimator of population mean. The sample mean is an unbiased estimator of population mean. So finally, it is justified that from a population 357, if we collect a sample of CES2, then the population sample mean is an unbiased estimator of population mean. Hence, it is proved. So, this is all about the system. There is another system. If we collect the sample with replacement, in that moment, just number of sample will be 9, that is n to the power n, that is 3 square equal to 9. And rest of the procedure is same. And if you try your sweet home, and I expect that you will able to justify the statement that sample mean is an unbiased estimator of population mean when we collect the sample with replacement. So it's highly important. In C or D of a creative question, you will get this question must. It is 100% you will get in a creative question. So no more today. Practice this question highly. Thank you very much. Allah Hafiz.